UC Irvine researchers created an E. coli-based water monitoring technology. What is it? How does it work? Well, we're going to find out with UCI News, bacterium used as a live sensor to detect heavy metal contamination. And we can see Regina Reagan, the UIC professor of materials science and engineering, says access to safe water is necessary for the health of people on the planet. New technology can be mass manufactured at a low cost and is needed to monitor the introduction of an array of contaminants in the water supply as a critical part of the solution for water security in the face of pollution and climate change. So what do? People often associate E. coli with contaminated food, and that is one way it can happen, but E. coli has long been a workhorse in biotechnology. Scientists at the University of California, Irvine have demonstrated the bacterium has further value as a part of the system to detect heavy metal contamination water. So, as we can see here, they have the contaminated water as a major source of toxic heavy metal for animals and people, and the metabolic stress response of E. coli used to detect the presence of toxic metals in tap water and wastewater, and difficult to detect heavy metal ions are thereby converted to more easily detectable chemical signals. So we can see the E. coli exhibit a biochemical response in a presence of metal ions and a slight change that researchers were able to observe with chemically assembled gold nanoparticle optical sensors. And through a machine learning analysis of optical spectra of metabolites released in response to chromium and arsenic exposure, the scientists were able to detect metals concentration 1 billion times lower than those leading to cell death. They're actually able to do that while being able to deduce the heavy metal type amount with higher than 96% accuracy. The process, which the researchers said can be accomplished in about 10 minutes, is a subject of study. This is a new water monitoring method developed by UCI researchers. It is highly sensitive, fast, and versatile. Co-author Regina Reagan, UCI professor of materials science and engineering, it can be broadly deployed to monitor toxins at their sources in drinking and irrigation water and agricultural and industrial runoff. This system can provide an early warning of heavy metal contamination to safeguard human health and ecosystems. In proving that bacteria like E. coli can detect unsafe water, the researchers spotlighted the other necessary components: gold nanoparticles assembled with molecular precision and machine learning algorithms, which greatly enhance the sensitivity of their monitoring system. Reagan said it can be applied towards spotting metal toxins, including arsenic, cadmium, chromium, copper, lead, and mercury, at levels orders of magnitude below regulatory limits to provide the early warning of contamination. In the study, scientists explained that they can apply trained algorithms to see unseen tap water and wastewater samples, which means the system can be generalized to water sources supplies anywhere in the world. This transfer learning method allows algorithms to determine if the drinking water was within the U.S. Environmental Protection Agency and the WHO recommendations for each contaminant, with greater than 96% accuracy and 92% accuracy for treated wastewater. Access to safe water is necessary for the health of people on the planet, she added. New technology can be mass manufactured at a low cost is needed to monitor the introduction of an array of contaminants in the water supply as a critical part of the solution of water security in the face of pollution and climate change. We can see that here. After heavy metal exposure of E. coli cells are examined with a sensitive optical sensor from gold nanoparticles, and the machine learning algorithms learn the chemical fingerprint of the stress response is unique to the type and quantity of the metal toxin from the optical spectra, and fine-tuned models determine if the unknown water sample is safe. So that's an interesting technology and definitely can be used actually for good. That being said, it's interesting to see E. coli being tested that way. It's interesting to see how they can use this type of technology, but E. coli can also have some negative effects, so it's always a good idea to test your water for E. coli and for other elements as well.